I know a lot of people are doing these videos right now about compressed air in an aeroplane. I just felt absolutely compelled to do my own one. I'm very lucky. I've asked someone if I could mirror their post, because obviously everybody's doing aeroplanes, and this one was Concorde, and not many people have done Concorde. So thank you to that person, and their name is in the post. Yeah. But I just wanted to do this video because I've just got this feeling, you know, the way I look at it, the truth, the whole thing. Look. I'm going to show a little bit of video, just very quick sections of videos of aeroplanes taking off and turning. Okay. We have had pilots on our panel, and what it is the pilots tell you that they put in the fuel for the flight. So if you're going to go to Paris, it will be so many gallons of fuel, and then if you go to say where can I pick, Malaga in Spain, because it's further, there'll be so many gallons of petrol going in the plane, right? So that means when the planes take off, say, to go to Paris, it won't be carrying as much fuel in it as the one that's going to Malaga. Yet when these planes take off, they veer to the right or the left or right up. So what I don't understand is these planes have tanks. I mean, they're supposed to be in the wings, and they're supposed to be in the body of the plane or the wings. But if they're not full, well, it doesn't matter if they're not full or if they're full. But once the plane takes off and veers to the right or turns to the left or goes straight up, that's going to make that liquid inside move. I just said, if you go to Paris, there's going to be less fuel in the plane than if you were going to Malaga. So that fuel is going to move. Now, just to put, obviously it's a very different kind of thing, but I was on the free sun tickets years ago. I went to France, but unfortunately 2 days later people got the Zeebrugge tickets, and if we remember what happened to that, the boat capsized. Yeah, so the boat was leaving port, and up until that point what they did was they would close the door as the boat was going out of port. So it meant the door was open when they were leaving, and then eventually, I don't know how many miles, a mile or two out of the port, the door then would have closed. Unfortunately this day, some water got in, surged in because the door wasn't shut on the ferry, and it capsized the ferry. Okay, and I would believe that if a plane had thousands of gallons or hundreds of gallons of fuel in it taking off, and it veered to the right, then that fuel would then junk to the right. I'm sorry, I know that maybe some of it would go with the plane because you're moving, but I'm sorry, that fuel would move. I just wanted to say one more thing. When you get on a plane that's nearly empty, they tell you where to sit because of the weight distribution on the plane. What difference does it make if there's hundreds of gallons of fuel chugging around in it when you're going up and turning and going round and off? It doesn't make any difference where you sit on that plane with all that fuel moving in the tanks. So I am under the belief as well that they are lying about fuel in aeroplanes. Yeah, maybe the first ones had fuel. I mean, in a sense, that's very unsafe, isn't it? It's unsafe having fuel like that, burning, engines, all that kind of stuff in an aeroplane where there's hundreds of people flying in it. It makes so much sense that it is compressed air. Yeah, but obviously there must be fuel in it for something, for the, I don't know what for, generators, there must be for something, to maybe start the engines, it's two things, maybe it's fuel and the compressed air which makes the engine work, but I'm pretty sure compressed air has to be a big factor in this. There's no way you could be chugging around in the sky with thousands of gallons of petrol moving around every time the plane turned to the right or went up a bit or down a bit, whatever. It just couldn't happen. That fuel would move, just like a wave machine, just like the ship would turn over. I think we've been duped, guys. I know somebody who's a friend of mine who I think yesterday was moaning at people for thinking that compressed air was used in aeroplanes to fly, and he said he knew better. But I can't see it that way. I just can't see hundreds and hundreds of gallons of fuel up there moving around in these tanks as the plane's going up and banking to the right. That fuel would move. That means the plane turns to the right and dips its wing down, and then the fuel would move down. Especially if it's in the wings. It doesn't make sense. It would crash the plane. And just to add, the reason that I'm adding the Zeebrugge thing, I know this is a ship and we're talking about aeroplanes in the sky, but what happened was, and I will just put a little bit of a news clip in to explain what happened, but water entered this boat and it capsized the boat because the water was moving. Now, I'm just saying it's the same thing with the fuel in the tanks. The fuel will be moving because the plane is maybe turning, taking off, coming down. I know there's a lot less fuel in the plane when it's landing, but, you know, when it's taking off and it's banking and things like that, these are sudden shifts. And quite, you know, they can be quite tight, some of these turns. And you know, with the wings right down. So this means the fuel would move down. I'm sorry, how could it be in tanks not be moving? What is it, compressed then? Anyway, so I'm going to put this bit in with Zeebrugge because this is explaining what happens when water is moving around inside something. In this case, a ship.
The evening of the 6th of March 1987, the Herald of Free Enterprise capsized so quickly that not even a distress call had been transmitted.
The ship just suddenly started to tilt a little bit, and we thought it was going to sort of stabilise itself, and then it went a little bit more, and then it just suddenly went, and I just went flying across. I couldn't do anything.
The Herald had been carrying 459 passengers, 80 crew, and a cargo of 131 vehicles. The Herald had berthed at number 12 dock at Zeebrugge, Belgium, but because of an unusually high tide, she had to flood her ballast tanks to lower her bow so that vehicles could load onto G-deck. This was the usual procedure in Belgian ports. The Herald did not have draft meters, so the captain didn't know how much clearance he had. It was the officer in charge's responsibility to correct the ship's trim at a later stage. On March the 6th, that officer was not on the car deck. Neither was the assistant bosun, whose job was to close the bow doors. He was asleep in his cabin. At 6:05, the Herald set sail. Her bow doors were still open.
The crew firstly forgot to close the doors, and neither did they check that the doors had been closed and put to sea before they should have done. Although I have to say that at that time it wasn't an uncommon practice to do this, certainly within a few hundred yards of the jetty.
Unaware of this, at 6:25, the captain pushed the engine speed from number 4 to number 6. Her speed was now approaching 15 knots.
Primarily, the Herald of Free Enterprise went to sea with its bow doors open. It was trimmed by the head, and as it built up speed, the bow wave started to enter the ship through the bow doors.
With heavy forward ballasting and an increased speed approaching 18 knots, the bow wave rose dramatically and flooded onto G-deck. No one could see or hear it, but the Herald was taking on water at a rate of 1,000 gallons a second. As queues formed for duty-free shopping and passengers enjoyed a meal, they were unaware that by now a total of 5,000 tons of seawater had flooded onto the ship.
Quick one, pick this book up by Haynes. They make the manuals for all your car maintenance, so these guys know what they're doing. Here we go. I got it from this bookstore here, The Works, £6. I think it was £6 well spent, as we shall find out. There's a girl lining the tanks with Kevlar liners, so the wings. So she must be the size of a rabbit. I'll explain why. 95,000 kilograms of fuel in all of these tanks. Right, I did did my usual production skills here. Right, I did save some. Right, so here we have a nice view with some people on the ground, but look at the skinny, tiny little wings. They are tiny. You know, probably the thickness, not even the thickness of this book, maybe. Okay. Right. So then we'll go on here. They're showing you there's various places where all the tanks are supposed to go in, but there's all these struts supporting the wing to give it strength, because obviously when you're flying supersonic, these wings are going to be subject to some immense strength, you know, forces and whatnot. But then also you've got to put room for the actual beautiful engines themselves underneath here. And anyway, let's carry on. This you can have you can screenshot this at your leisure, or buy the book. You know, I am recommending buying the book because it wasn't expensive. I've done that page. Sorry. And there's what did it say here? Smoky Joe's. Well, nitrogen oxide. Nitrogen. If you're separating the air, which I'm telling you these engines do, nitrogen oxide will cause this smoking effect. I do believe I read about that. Here's the fuel gauges. Kilograms per hour. That's how you could measure airflow, yeah? Okay. Another gauge here. PSI. That's how you measure pressure of air in your tyres. Here's some more. Sorry about this light, it's not great. Here's showing you the tiny thin. Look how thin those wings are, yeah? And there's the engine. You can crawl inside that bit, but that bit you're not going to crawl inside there. And what I'm saying to you, that picture was faked. More pictures. I mean, it's a marvel of engineering, an absolute marvel. Excuse me. And if I can get there you are. Absolute. There's these are steps designed for a human to walk up, not a giant. And the steps have you can look them up. They're a certain size so you don't trip. And then look at the tiny little wings. There's no liquid fuel gone into any of this, is what I'm getting at. Anyway, I may have done this before. You can find this on Google or other search engines. Gas turbine engine. Sorry, the gas turbine is an internal combustion engine that uses air as the working fluid. The engine extracts chemical energy from the fuel and converts its mechanical energy using the gaseous energy. So the chemical energy is the gaseous energy, or the working fluid, which is the air. Down here, a large mass of air must be supplied to the turbine in order to produce the necessary power. The mass of air is supplied by the compressor, which draws the air into the engine and squeezes it to provide high pressure air to the turbine. Now, I'm just going to read this next bit because this is the crux of it to me. Right, if the compressor and turbine were 100% efficient, the compressor would supply the air needed by the turbine. At the same time, the turbine would supply the necessary power to drive the compressor. In this case, a perpetual motion would exist. That's where it should end, because they have invented a perpetual motion free energy generator. And I just want to end it there, because then the rest of the book and the rest of I've got another book as well. That's a similar sort of price, showing you. I mean, they're absolutely fabulous, amazing pieces of engineering, but unfortunately, you get people like that don't want you to know because they're very highly paid, and it was an elitist thing to become a pilot. There was jokes, Jeff in the RAF and Tally-Ho boys and all that in the day, because the elite, I mean, they were showing you these ridiculous things, but it's the engine itself is the marvel, and the weight of these things, the whole thing, it's a lie. The whole industry are lying to you because they've invented a free energy generator and hidden it in plain sight. Anyway, there you go. Just me. I'm in the process of binding up another book. I'm binding these up for myself, for when I get a chance in the future to sit down and read them, or maybe for my children to read them if they're interested in it. I'm not going to force them. But you know, it's nice to have the reference material before it disappears from existence. Anyway, I'll leave it there. Thanks a lot.